Hello again, students. It's time to practice some of the things that we just reviewed about logical reasoning. This practice page is broken down into the 4 parts of the SOL. You can see on the left-hand side that we'll be studying conditional statements, symbols of logic, Venn diagrams, and deductive reasoning. Let's check out number 1 here. It says, write out the converse, inverse, and contrapositive of this statement. If Joe goes fishing, then he needs bait. Well, if I check out my notes from the previous video, I know that I'm working with the 3 different conditional statements here, but first I need to label the original statement, P and Q. Well, the 2 parts of this statement are Joe goes fishing, and the second part is he needs bait. So for this example, Joe goes fishing will be my P statement, while he needs bait will be the Q statement. With the converse, I can check my notes again. The converse's job is to switch the hypothesis and conclusion. Symbolically, that's where Q and P switch positions. Therefore, the original conclusion becomes the hypothesis, and the original hypothesis becomes the conclusion. I'm going to pause for a moment and write this sentence up. My converse will now read, if Joe needs bait, then he goes fishing. I'm going to highlight that original Q statement. He needs bait. Here it is now as the hypothesis. Joe needs bait. I'm also going to highlight the original P statement. Joe goes fishing. As you can see, the colors have switched positions. The original hypothesis has become the conclusion. The original conclusion has become the hypothesis. Next, we're going to tackle the inverse statement. Check out your notes again. The inverse statement negates the hypothesis and conclusion. We use these squiggles to represent the negation of P and the negation of Q. Well, the easiest way to negate a statement is to state the opposite. Instead of if Joe goes fishing, I'll want to say if Joe does not go fishing. Instead of saying then he does need bait, I want to say he does not need bait. I'm going to pause my video while I write these up. Okay, now I've written up my inverse statement. I want to use my highlighters again to show you how P and Q have not changed position. The original hypothesis is Joe goes fishing. Now my hypothesis is Joe does not go fishing. I've inserted does not because the inverse requires us to use a negation. The second part of the original statement is he needs bait. The second part of my inverse statement says he does not need bait. Again, we've inserted the negation of the original statement. The final statement I'm asked to build is the contrapositive. The contrapositive statement negates the original and swaps the position. Let's check out our notes. We can see in our notes that the symbolic version of the contrapositive negates P and Q and also switches the order of P and Q. Therefore, the conclusion of the original is negated and turned into the hypothesis. The hypothesis of the original is negated and turned into the conclusion. I'm going to pause the video while I write up the contrapositive. Okay, so let's read through the contrapositive. If Joe does not need bait, then he will not go fishing. The conclusion of the original statement is he needs bait. I've moved that statement to the beginning of the contrapositive, and I've also included the negation. The hypothesis of the original statement is Joe goes fishing. I've moved that to the end and negated that statement. Okay, let's try one that's been done for us. Here in example number 2, it says, how is statement B related to statement A? Well, statement A says, if the two angles are not vertical, then the angles are not congruent. Statement B reads, if two angles are vertical, then the angles are congruent. Pulling out my highlighters again. Statement A, if the two angles are not vertical, that would be the hypothesis. And the conclusion is, then the angles are not congruent. I've highlighted everything except the knots in there. The second statement reads, if two angles are vertical, then the two angles are congruent. This hypothesis is the same as what I've highlighted in statement A. However, it does not include the word not. The same thing's happening in the conclusion. The angles are not congruent has changed to the angles are congruent. What this is showing me is that the two statements have not swapped order. If I go back to my notes, there's only one of the forms of the conditional statement that does not swap the order, and that's the inverse. Converse swaps order, contrapositive swaps order and negates. The inverse maintains the original order, but negates the hypothesis and conclusion. Statement A and statement B are inverses of each other. Okay, let's move on to the symbol of logic here. Slide this up a little. Let's see what we're asked to do. It says if the conditional statement, if you have a laptop, then you have a computer, is represented by P to Q, then what is the symbolic representation of if you have a computer, then you do not have a laptop? Here I come with my colors again. In the original statement, the hypothesis is you have a laptop. If I come down here to the second statement, I see you do not have a laptop in the conclusion spot. However, it's been negated. Okay, the original conclusion is you have a computer. In the second statement, you have a computer has not been altered, however, it has been moved to the front of the sentence. So if I need to rewrite this using symbolic representation, notice that the original P statement, you have a laptop, has been moved to the end of the sentence and has been negated. The original Q statement, you have a computer, has not been changed, but it's been moved to the beginning of the sentence. This is still an if-then conditional statement, so I still need to include the arrow that translates to if-then. Here's one for us to write up ourselves. Example 4 says, let P equal a polygon has 5 sides. Let Q equal a polygon is not a pentagon. And we are to take these two statements and translate the following. What is the verbal expression of the following symbolic statement? They've taken statement P and negated it. So I need to change a polygon has 5 sides to a polygon does not have 5 sides. Q has not changed, so I won't need to change Q at all. The arrow in between tells me that this is going to be written in if-then form. I'm going to pause the video while I write up my statement. Okay, let's see what I've come up with. The original statement, or the original P, was a polygon has 5 sides. This asks me to negate that statement. Here's the original P statement, a polygon has 5 sides. However, this squiggle out front tells me to negate that statement, so I've included a does not in there. The Q statement is a polygon is not a pentagon. I have not changed that statement at all. It's not a pentagon. You'll see with the arrow in there, I also have included the words if and then. Okay, our next area to refresh is Venn diagrams. Here I've got a very complicated Venn diagram that's combining 4 different categories. It says this Venn diagram represents students who play instruments in the orchestra. We've got clarinet players, oboe players, flute players, and bassoon players. We're asked to find the region that represents a different set of students. We have to read carefully because we're going to need to compare the ands versus the ors. First, we're asked, which region represents students who play the clarinet and the bassoon? That word and means we need to find the regions that are overlapping between the clarinet bubble and the bassoon bubble. I'm going to cover up this half of the picture. We don't have any discussion about oboes or flutes. Here, clarinet and bassoon has several regions that have been overlapped. This region I've shaded with my pencil is both in the clarinet space and in the bassoon space. That means regions 2, 3, 6, and 5 all represent students who play the clarinet and bassoon. Next, we're looking for which regions represent students who play the oboe but not the flute. Well, first, I think what I'm going to do is shade every single region that represents students who are playing the oboe. That's every single region in the oboe bubble. Then, I'm asked to exclude the students who are not playing the flute. So I'm going to go back in here and erase the shading that includes the students in the flute bubble. This leaves sort of a crescent moon-shaped region to describe. Zone 3, Zone 7, and Zone 9 represent students who play the oboe but who don't play the flute. Our next challenge is to find the region that represents the students who only play the flute and bassoon. Only is a very exclusive word, whereas and is an inclusive word. We need to find the zone of bassoon and flute players, which we did in our very first problem here. It's this football-shaped area. But now we're asked to represent the area of students who only play bassoon and flute, which means they can't play any other instrument. So I'm going to go in and erase our oboe players and our flute players. Next, we're asked to find the region that represents the students who only play the bassoon and the flute. Well, first I'm going to identify the region of bassoon and flute. This region of overlap between bassoon and flute is sort of a football-shaped zone. However, the question says which region represents the students who only play bassoon and flute. So I need to go back and erase our clarinet players and erase our oboe players. That leaves me this one region, number 11. That is the only region where students are playing bassoon and flute, but nothing else. Our last challenge is asking us to identify the region that represents students who play the clarinet or the flute. Or is a very inclusive word. This means we are trying to find all the students who play the clarinet and all the students who play the flute. First, I'm going to shade in all the areas where students are playing clarinet. Now I'm going to go back and shade in the regions that represent students who play the flute. If this were an and statement, I would need the area of overlap. But since this is an or statement, I'm including every piece of the shaded zone. That includes region 8, 7, 5, 3, 6, 2, 1, 4, 10, 11, and finally 13. Notice how or is usually a much larger set, and that's because it's inclusive of all parts. Our final practice problems will be working towards understanding deductive reasoning. Remember, there are two laws of deductive reasoning. One is called the law of detachment, which follows the pattern if P then Q, followed by a statement about the hypothesis, concluded with a statement about the conclusion. The other law of deductive reasoning is called the law of syllogism. Here we have 3 if-then statements. The key is that the conclusion of the first statement is the hypothesis of the second statement. Its job is to connect the original hypothesis to the secondary conclusion. Let's check these two examples out. Example 6. What is a valid conclusion that can be drawn from these two statements? If a quadrilateral is a rhombus, then it's a parallelogram. If a quadrilateral is a parallelogram, then its opposite angles are congruent. We've already started out with 2 if-then statements. Statement number 1, if a quadrilateral is a rhombus, then it is a parallelogram. Statement number 2, if a quadrilateral is a parallelogram, well, hold up right there. We have already used this idea about a parallelogram in the conclusion of the original sentence. We're now using it as the hypothesis of the second sentence. That means Q, statement Q, is being repeated. The final statement here is, then its opposite angles are congruent. That's a fresh idea. We call it R. Well, so far we're following the pattern of the law of syllogism. The original conclusion has become the hypothesis of the second statement. The law of syllogism says, if the original statement is connected to the second statement this way, then we can form our final conclusion using the original hypothesis and the second statement's conclusion. I'm going to pause while I write up my final conclusion. Let's read through my final statement. If a quadrilateral is a rhombus, then its opposite angles are congruent. Let's read the whole thing and see how it all flows. Statement 1, if a quadrilateral is a rhombus, then it's a parallelogram. If a quadrilateral is a parallelogram, then its opposite angles are congruent. Therefore, if a quadrilateral is a rhombus, then its opposite angles are congruent. In our final statement, I've connected the original hypothesis to the second statement's conclusion. This is the law of syllogism. Our second example and final example of this video asks the same original question. What is a valid conclusion that can be drawn from these two statements? Let's read the statements. If I get good grades in high school, I will be going to college. Second statement, I got all good grades. Let's form our conclusion. Here we started with an if-then statement. The hypothesis of the original statement is, I will get good grades in high school. In the second statement, it refers to the hypothesis again. I got all good grades in high school. So it should be a logical conclusion to finish this statement using the conclusion from the original statement. Pause the video while I write my answer. My final statement will fulfill the law of syllogism. If I get good grades in high school, then I will be going to college. I got all good grades. Therefore, I will be going to college. This fulfills the pattern of the law of detachment. And with that, we finish our study about all of logical reasoning that is studied in SOL G1. Thank you for watching, and good luck.